This is group 36 and we'll be presenting on pyrometallurgy. So we start with the introduction to pyrometallurgy. So first of all, we have to know what pyrometallurgy is. So what is pyrometallurgy? And pyrometallurgy is a branch of extractive metallurgy. It is also a branch of chemical engineering that focuses on the use of high temperature processes to extract and refine metals from their ores. It's a critical field that enables the production of essential materials for modern society. So when you come to our modern societies, most essential materials are made through pyrometallurgy. So we will then move to the principles of pyrometallurgical process. And we'll start with high temperatures. So in pyrometallurgy, we need processes such as high temperatures, controlled atmospheres, and energy efficiency. So in high temperatures, it says pyrometallurgy process rely on extremely high temperatures, often over 1000 degrees Celsius, to facilitate chemical reactions and phase changes that separate metals from their impurities. So we can see that the process rely on chemical reactions, and we know that for chemical reactions to mostly occurs, like we need to like higher the temperature. The temperature must be high. So this means that the process will also depend on high temperatures. So we then move to the controlled atmospheres. So the controlled introduction of gases like oxygen, hydrogen, or inert gases is crucial to drive specific reactions and maintain the desired conditions. So the conditions for the process occur. We also need to control the introduction of gases. Yeah, the inlet and the outlet of gases matters. Okay. So next we move to energy efficiency. Um the process also depends on the energy efficiency. So pyrometallurgists they mostly strive to maximize energy efficiency by sometimes recovering and reusing waste heat and optimizing furnace and reactor designs. So we will get to know furnaces and reactor designs in our next slides to come. Our next slide, high temperature metallurgical processes, which is also known as the processes of pyrometallurgy. Um, they include roasting, smelting, refining, and casting. And I'll start with the roasting. The roasting is a process of heating ores to a high temperature in the presence of air. The ores subjected to roasting are mostly purified by froth flotation. And roasting is a complex separation technique. Yeah, it is a complex technique of thermal gas liquid reactions. And the thermal gas liquid reactions they include the oxidation, the reduction, chlorination, sulfonation, and pyrohydrolysis. Okay, so let's move to smelting now. Smelting is a reduction of metal oxides to pure metals using reducing agents like carbon or hydrogen at extremely high temperatures. The smelting is also a process by which a metal is obtained, and it is obtained either as the element or as a simple compound by heating beyond the melting point. So if you are able to heat a metal beyond the metal point, it means and we get it as the element or the simple compound. The process is called smelting. The process is called smelting. So we move to refining, which is also um simply purification of an impure metal, which is also It is simply purification of an impure metal. Yeah. And the techniques that we use in the refining are distillation, electrochemical processes, or further chemical um, treatment. Um, it is different from smelting. It is different from smelting. They mostly involve a chemical change to the raw material. And in refining, the final material is usually chemical to identical chemically to the original one, and it is purer. Yeah, it is very pure. And lastly, casting. The casting talks about pouring molten metal into molds to create solid metal products with desired shapes and properties. Okay, so this is when after all the process, roasting, smelting, refining, we get a molten form of the metals, and we have to create it into molds, yeah, into different kinds of shape. So this process is called casting. Okay, so now we are at roasting and calcination technique. So before we continue, let me first of all talk about calcination. We already know roasting, so let's talk about the calcination. The calcination is a thermal treatment process, and it is done sometimes in the absence of oxygen. Um, Causes of the calcination are the thermal decomposition, the phase transition, removal of a volatile fraction, and it normally takes place at temperatures below the melting point of product materials, and it is mostly used in carbonate ores. Okay, so now that we know calcination now, let's move to our techniques. So I'll start with oxidation, and oxidation is a driving of volatile components and converting metal sulfides or carbonates to oxides through controlled air exposure. So we all know that volatile components are they are components that evaporate at lower temperature, right? And you see, uh, in our previous slides, we talked about the controlled air exposure. As you can see, we need it in the hot, in the oxidation, where we drive off the volatile component. Okay, so after the oxidation, we then move to the temperature control. So the temperature control, precise management of temperature profiles to achieve the desired chemical and physical transformations. Okay, so in we need to control the temperature to avoid underdeveloped or burning of hot we are roasting. Yeah, example, roasting of coffee. If we are not able to control the temperature very well, it's either we burn the coffee, or the coffee becomes underdeveloped. Yeah, so the temperature control, it really matters in the roasting process. And lastly, we talk about the residence time. So in the residence time, we carefully control the duration of the roasting or calcination process to ensure complete reactions. Okay. Okay, so we then move to smelting and reduction processes. So the process include all preparation, charge composition, smelting, and production separation. So let me summarize the process. So during this process, the ore is crushed. Yeah, the ore is crushed, and the after crushing the ore is melted at high temperatures, and reducing agents or a material called flask is inserted in. When the flask is inserted in, the flask bond with impurities and segregates them from molten metal. So in the end, metal falls to the bottom of the furnace and flask, and impurities create a layer called slag. Yeah. So after everything, the molten metal from slag and other impurities through density difference and controlled solidification. After that, everything is solidified. Okay, so pyrometallurgical furnace design. So we are going to design the furnace. A refractory. First of all, we need the refractory materials, the heat transfer, and the process control. Okay, so uh, in material science, a refractory is a material that is resistant to decomposition by heat or chemical attack that retains its strength and rigidity at high temperatures. So, the choice of specialized heat-resistant bricks, ceramics, and coatings is critical for furnace longevity and performance. So, if we want our furnace to perform well and um, stay for a long period of time, we have to choose the right refractory materials. Then we move to the heat transfer. In the heat transfer, we optimize the design of heating elements. Yes, gas flows and insulation to achieve efficient heat transfer and heat and energy utilization. So we should be able to optimize a design of heating elements that we are able to achieve a heat transfer, and we are also able to utilize the energy. So then lastly, we move to the process control, and this talks about the implementing advanced sensors, computer monitoring, and automated controls to precisely manage the furnace parameters. So this is I think this talks about technicality. Yes, your furnace should be able to um, control and manage its furnaces, and that's the process control. Modeling and simulation in pyrometallurgy. We have mathematical modeling, process optimization, and lastly, computational fluid dynamics. So, what is mathematical modeling? The mathematical modeling is the activity by which a problem involving the real world is translated into mathematics to form a model which can then be used to provide information about the original real problem. So developing detailed models to predict the behavior of pyrometallurgical processes based on fundamental principles of chemistry, physics, and engineering. The next is process optimization. We should be able to it is the leveraging model and simulation to explore design alternatives, identify optimal operating conditions, and improve the efficiency and performance of pyrometallurgical processes. So this one talks about how we were able to design alternatives um, to assist in the process of pyrometallurgical systems. And lastly is the computational fluid dynamics. And this it is the using CFD simulations to analyze the complex flows of gases, liquids, and solids within pyrometallurgical reactors and furnaces. So the flows of the gases, liquids, and solids are like and solids matters in the pyrometallurgical process, and this can be done by the help of the computational fluid dynamics. Let's not also forget about environmental consideration in pyrometallurgy. As an engineer, when you discover something, you have to you have to make sure that it doesn't have any effects on the environment. So the environmental consideration in pyrometallurgy, we will talk about the emission control, waste management, energy efficiency, and regulatory compliance. So let's start with the emission control.
we should be we should be able to implement advanced pollution control technologies to minimize the release of hazardous air pollutants, particulates, and greenhouse gases. As we already know that all these affect the environment and the atmosphere. These hazardous air and pollutants can cause like undiscovered diseases. So we should be able to control the emissions by implementing advanced technologies. Next is waste management, developing sustainable approaches for the handling, treatment, and disposal of solid and liquid wastes generated by pyrometallurgical operations. So the waste that we get from the process, like the waste we receive after the pyrometallurgical process, we can manage the waste. The waste can be used for anything useful that we can also gain um more from it. Yeah. So we should be able to manage the waste from the pyrometallurgical processes too. And we should energy efficiency, optimizing energy usage and recovering waste heat to reduce to overall environmental impact of pyrometallurgical process. So we should be able to optimize the energy usage too, and we should recover the waste heat, and to reduce the impact. So we should make sure that we are able to use the energy efficiency, and the waste heat too. We must able to reduce it so that it doesn't have an effect on the environment. And lastly, regulatory compliance, which ensuring strict adherence to environmental regulations and industry standards to protect workers, communities, and surroundings. So when in the pyrometallurgy um, sites, there should be rules and regulations which will guide the workers or anything surround anything in the that is in the pyrometallurgy process. They should be given rules to guide them and make them do the right thing, yeah, to avoid any accident. So we are talking about how the pyrometallurgical we can make it environmentally friendly, and we can we can achieve this by emerging trends and innovations. So process intensification. We should be able to develop more compact, efficient, and sustainable pyrometallurgical technologies to reduce energy consumption and environmental impact. So we should be able, in this modern world, we can create technologies that will help us reduce energy, yeah, and also have a great impact on the environment. Next thing is generating AI. We should be able to leverage advanced data analytics, machine learning, and simulation tools to optimize and automate pyrometallurgical process. Artificial intelligence is now common in this modern society, and it helps solve most problems. So if you are able to leverage or advance the AI or generate AI or introduce AI in the pyrometallurgical process, we will be able to have a great impact on the environment. Circular economy, transitioning towards closed loop pyrometallurgical systems that maximize resource recovery and minimize waste generation. So this circular economy, it is able to maximize resource recovery. We can recover more resources, and it will help reduce waste generations. So now, lastly, on our last slides, we will talk about the pyrometallurgy applications in chemical engineering. So we have metal production. extracting and refining metals like iron, copper, aluminum, and precious metals from their ores. Through the pyrometallurgical process, we are able to extract and we are able to refine metals. Waste recycling, recovering valuable metals from electronic waste, slag, and other industrial. We can also be able to recycle waste, yes, through the pyrometallurgical process. The next one is material processing. Products, byproducts producing specialized materials like ceramics, glasses, and refractory products through high temperature treatment. So we are able to get all these materials, yeah, that's the ceramic, glasses, and refractory, through the pyrometallurgy process. And lastly, energy generation, utilizing pyrometallurgical process for the production of fuels such as coke and charcoal for power generation. So the pyrometallurgical process also help generate energy by utilizing or by producing fuels. Uh, so this ends our introduction to pyrometallurgy. Thank you.